This is Algebra 2, Unit 4, Lesson 3, Exponential Function Basics. Now, in this unit, we're going to be looking at exponential functions. We first saw these back in Common Core Algebra 1, so we are going to review some of the basic components of their graphs and their behavior. Okay, so let's take a look at the basic exponential function. Its formula is y equals b to the x. All right, now notice it's exponential because your x value is an exponent. And b has to be greater than 0, and b can't equal 1. So their base here can't be 0 because you can't raise anything to the 0 power, and b can't equal 1 because every 1 at every single time. All right, so let's take a look at what this function looks like and how it behaves. All right, so let's consider the function y equals 2 to the x. So let's fill in the table without using your calculator and then sketch the graph. Okay, if x is negative 3, this would be 2 to the negative 3. Now, how do you rewrite 2 to the negative 3 as a positive exponent? It would be 1 over 2 to the third, which is 1/8. Okay, so negative 3, 2 to the negative third is 1/8. All right, what's 2 to the negative 2? 2 to the negative 2 is 1 over 2 squared, which is 1/4. All right, so what's 2 to the negative 1? Would be 1/2. All right, so that brings us 2 to the 0 power. Anything raised to the 0 power always equals 1. And then we can just fill in the rest of them. 2 to the first power is 2. 2 squared is 4. 2 cubed is 8. All right, so let's graph these. All right, so negative 3, 1, 2, 3, 1/8 would be about there. Negative 2, 1/4 is a little higher, not very much. Negative 1, 1/2 would be there, and then at 0 you're at 1, and 1 you're at 2, then 2 you're at 4, 1, 2, 3, 4, and then at 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. All right, so notice on here, when you do your graph, an exponential function is a curve, all right, because we are increasing each time by multiplying. All right, so your base here, y equals 2 to the x, is a positive 2, so it is increasing as you move from left to right. Okay, now let's look at the function y equals 1/2 raised to the x power. So let's use the calculator and fill out the table, and we'll sketch it in just a second. All right, so y equals 1/2 to the x. First thing I want to do, when I go to my calculator, go to the y equals screen. 1/2 has to be in parentheses because I'm raising the entire thing to the x power. Raised to the x power. Go to my table. All right, so I wanted negative 3 is going to be 8. So if I go to my table, my table that I have here, 1/2 to the negative 3 would be 8. Now that makes sense when you're talking about it because this is 1/2 to the negative 3. This would flip this, basically, and become 2 over 1 to the positive third. 2 to the third is 8, and that's what it works out to be. Okay, now, 1/2 to the negative 2, we said was 4, and then 2, and then 1. There's 4, 2, 1, because anything raised to 0 power is always 1. 1/2 to the 1 is just going to be 1/2, or 0.5. All right, 1/2 squared will be 1/4, or 0.25. And 1/2 to the third will be 1/8, is 0.125. So there's my values. All right, now let's see what happens when I graph these. Negative 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. It's right there. Negative 2 is at 4, 1, 2, 3, 4. Negative 1 is at 2. 0 is at 1. 1 is at 1/2. 2 is at 1/4, or 0.25, and 3 is at 1/8. It should be right about there. And then drawing your line down, it should be a nice curve, or as close to a curve as you can draw, which I'm not good at drawing. Whoops. Get that last section right there. Okay, so there is my curve, like so. So this one is y equals 1/2 to the x. The other one was y equals 2 to the x. So what did we notice about these two graphs? Well, what we notice here is when your base value is a fraction, what is the function doing? It is decreasing. As you move from left to right, it is going down like this. It's a curve like this. What happened when the base was 2? Back here. When the base is 2, it's going to be increasing as you move from left to right. So the curve will look like this, and for the decreasing, the curve will look like this. All right, so based on the graphs and behavior you saw in exercises 1 and 2, state the domain and range for an exponential function of the form y equals b to the x. Okay, so when we're looking at my two functions, here is y equals 2 to the x. This was increasing. Is there any value of x here that does not work for this function? No. All the values of x are going to work. If I keep going to the left to right, this is going to keep increasing this up, and as I go to the left, it's going to keep decreasing. All right, now the same thing would be true for this one. As I move to the right, it's going to be decreasing. It's still going to have x values, and to the left, it's still going to have x values. So on this particular one, the domain is going to be all the real numbers. So the domain is all real numbers. There is no value of x that you cannot use. So this would be, that's a symbol for our real numbers. Okay, the range would be the y values. Now what did you notice about these y values? Here's y equals 2 to the x, and here is y equals 1/2 to the x. What do you notice about the y values? What do they never fall below? The y values always have to be above the x-axis, which the y values would have to be greater than 0. Now, can they actually equal 0? Well, if I have a value here, if I raise something to a power, can it ever equal 0? No, it can get microscopically close. Notice this is still going to keep getting smaller and smaller and smaller and smaller, but it'll never actually hit 0. So your range for this output set for both of these is going to be y is greater than 0. So it can only have positive outputs. Okay? Now our exponential function's 1 to 1. Now remember, 1 to 1 means each x has only one y. That's what 1 to 1 means. What kind of test do we tell about them? All right, a 1 to 1 function is a horizontal line test. And if it hits it in more than one spot, then it will be then it won't be 1 to 1. If it only hits it in one spot, it's 1 to 1. So if I drew an imaginary line across like this, is there any place that I would hit the graph more than once? No. All right, if I do the other one, if I draw a horizontal line, I'm only going to hit the graph once. So is this 1 to 1? Yes. So exponential functions are 1 to 1 because they pass the horizontal line test. Okay, now what does this tell you about their inverses? Well, remember the reason we do 1 to 1 is to tell what kind of, if their functions have an inverse or not. So this tells us that the inverse of the exponential function is also a function. It has an inverse. You can do the inverse of the exponential function. All right, let's try a couple more exponential functions. Let's consider the functions y equals 7 times 3 to the x. Let's determine the y-intercept of the function algebraically. Algebraically means use algebra. So when we talk about the y-intercept, what do we know about the x-coordinate and the y-coordinate? Well, we know the x is going to equal 0. So if I plug in y equals 7 times 3 to the 0, this is 3 to the 0 is going to equal 1. It's going to equal 7. All right, so my y-intercept is going to be 7. All right, does the exponential function increase or decrease? All right, now whether it increases or decreases is based on the base value. The base here is going to be 3. So that means it's going to increase because the base value that you're multiplying by 3 each time, because the base 3 is greater than 1. So if your base that you're multiplying by, this number right here, that has the exponent on it, that's the base. If that's greater than 1, then it's going to increase. Okay, so if I want to create a rate of sketch, I know it's going to be going up like this. The y-intercept is going to be 7, and it's going to go approximately kind of like this. It's going to look something like that if I were to graph that. Okay, because this would be the y-intercept at 7, and it's going to be increasing. So it's got a general shape of increasing as you go left to right. All right, let's try one more. All right, consider the function y equals 1/3 to the x plus 4. How does this function's graph compare to that of y equals 1/3 to the x? What does adding 4 do to a function's graph? Okay, so what does the plus 4 do? Remember we did the transformations of the functions? Plus 4 does what to the graph? It shifts the graph what direction? It's going to shift the graph up 4 units. Okay, so determine this graph's y-intercept algebraically. Remember, when they do the y-intercept, x is going to equal 0. So y equals 1/3 to the 0 power plus 4. 1/3 to the 0 is 1, plus 4 is going to equal 5. All right. Now, that makes sense when you think about it, because if we're doing the regular exponential function, 1/3 to the x, where would the y-intercept be? It would be at 1, because if you raise to the 0 power, it's going to be 1. And then you shove it up 4, you're going to be at 5. So instead of being at 1, you're going to be up 5 here. Okay, now, this is going to be my y-intercept at 5. What is this function doing? It is decreasing. All right, why do I know it's decreasing? It is decreasing because the base value is between 0 and 1. So basically a fraction. Well, I should say not necessarily a fraction less than 1. All right, so your base is between 0 and 1. Okay, so that means it's going to be decreasing. So it's got to look like, kind of like that. All right, it's got to be decreasing. So 1/3 to the x would actually be down here somewhere. And we just shoved it up at 1. So if this is y equals 1/3 to the x, approximately, this is going to be y equals 1/3 to the x, shifted up 4 units. So it's going to slide up 4. Okay. All right, so that's the basic review of the exponential function. You need to know what the y-intercept is, what the base is, what the exponent is, and how to tell if a function is increasing or decreasing based on what the base is.